So next we have what we're referring as rounding and chopping. So in rounding, so which we use already. So when we say rounding, so we look at the last term. Okay, so if the term where we are rounding it off, so it would be from if it is less than or equal to 5, okay, or I mean less than 5, so we retain, okay, so we retain the last term. But if it is equal to 5 or greater than 5, then we add 1, okay, so on the last term. So that's the rounding off. But in chopping, so when we say chopping, regardless, okay, so whatever is the last term, so let's say we write the first 3 significant figures, so we look at the 3 significant figures, regardless whatever is the 4th significant figure. So we just totally remove or we truncate those. So next we have the Taylor series. So in Maclaurin series, so we are given a series for a certain function. Okay, so each function would have a different Maclaurin series. But a special case of the or this is the more general formula. Okay, so for the Maclaurin series is taken from the Taylor series. Okay, so the Taylor series is a formula so that we are, or it's a series so that we are using in evaluation of certain function. Okay, so if we want to predict a certain value, so using the Taylor series, so we can do that here. There are multiple orders. Okay, so in terms of the accuracy, so whenever we are using the Taylor series, so for the zero order approximation, so when we say x sub I plus 1, so you're familiar with this in computer programming. So I plus 1, so that means that's the next term. So I is the previous term. Okay, so the next term is I plus 1, and then I is the previous term. Okay. So if we want to predict a certain value of the function, so let's say initially we treat x to be equal to 1, and then I want to get what is the value of f of 1. So in here, so I could consider that my next value, x sub I plus 1, is equals to 1, because that is where I am predicting. Okay, so what would be the value? What is f of 1? But instead of using 1, so I use the starting approximation, which is 0, until I'll be able to find what's the value of f of 1. So for the Taylor series, so for the zero order approximation, it's just simply substituting, okay, or evaluating what is f of x sub I. Then for the first order approximation, so I need to find, okay, so what is f prime of x, and then afterwards, so I'm going to evaluate it using x sub I. And then x sub I plus 1 minus x sub I, okay, so that is the step index, or others refer to that one as h, and that is simply x sub I plus 1 minus x sub I. So in this case, if I would have x sub I plus 1, which is 1, and x sub I is 0, is 1 minus 0, so therefore h is equals to 1. So that's the step index then, which is 1. For the second approximation, as you can see here, it's the same as in the Maclaurin series. So we start with 0, okay, actually this is f of 0, x sub I, and then we have the f prime, and then f double prime. Succeeding would be f triple prime, then f fourth prime, and then the factorial. So we start with 0 factorial, this is 1 factorial, 2 factorial, and then 3 factorial. And then the first one here, we just have x sub I plus 1 minus x sub I raised to 0, so that is why it would just retain as 1. And then this one is raised to 1, then raised to 2, succeeding would be raised to 3, and so forth. So that's why this would be the nth order approximation. So for the simplified Taylor series, so this is the formula that we will be using. So for first order approximation, we start with the first term. Second order, or zero order, that's a zero order. First order, would be the first two terms, third order the first three terms, and so on. Okay? So let's say we are given f of x, so which is this negative 0.1 x to the fourth minus 0.5 x cubed, and so on and so forth. So we are given x of I, so initial, so to be 0, h is 1. Since x of I plus 1 is already given, which is 1, so we can even verify that that is x of I plus 1 minus x of I, so which is 1 minus 0, it's still 1. So h is still 1, although it was already provided on the example. So in this case, so we are to approximate what is f of 1. Okay? So for the true value of f of 1, so for true value, so what would be, in short, so what is f of 1? So f of 1 then, so we are given the f of x, so which is negative 0.1, so times 1 raised to 4 minus 0.15, 1 raised to 3 minus 0.5, 1 squared minus 0.25 times 1 plus 1.2. So our f of 1 then, so it's just simply negative 0.1, so 1 raised to 4 is still 1. So minus 0.5, it's minus 0.15, and minus 0.5, minus 0.25, and then plus 1.2. So the answer is 0.2. So the true value, in short, if we're going to evaluate what is f of 1, then that is equal to 0.2. So that is for the true value. Okay, so that is only for the true value. So now is what is our task is what is the approximate? Okay, so what's the approximate value of f of 1 using our initial assumption? Okay, so that our x of I is equals to 0. So now, so we use the zero order approximation, or that's just simply the first order. Zero order approximation. So for the zero order approximation, so using the Taylor series, it says that f of x of I plus 1, or just simply f of 1, or let me write it, f of x of I plus 1 is approximately equal to f of x of I. So in short, f of 1, x of I plus 1 is 1. So approximately equal to f of x of I is 0. But then 0 is, so using the same function, f of 0, so we have negative 0.1, so times 0 raised to 4, minus 0.15, 0 cubed, minus 0.5, 0 squared, minus 0.25, 0, and plus 1.2. So it would appear that everything is 0, so therefore this would be 1.2. So for the zero order approximation, zero order, so that means this is 1.2, and then the true error, that is 1.2, or sorry, the true value, which is 0.2 minus 1.2, so divide it with the true value of 0.2. So we take the absolute value, so which is 0.2 minus 1.2 over 0.2 times 100. So that is around 500% error. Okay, so that's too far. And then for the approximate error, so we don't have the previous value, so that will be skip. So next we have the first order. For the first order approximation, that is f of x sub I plus 1, so approximately equal to f of x sub I, so plus f prime of x sub I times h. But then our f of x sub I is 1.2. Or before I even do that, so let me get first what is f prime of x sub I. So f prime of x sub I, so I'll start with this one. This is f of x. So we derived, so let me write the f of x. Which is negative 0.1 x to the fourth minus 0.15 x cubed minus 0.5 x squared minus 0.25 x, then plus 1.2. So our f prime of x then, so will be, so 4 times negative 0.1 so we have negative 0.4 x cubed, then 0.15 times 3, that is negative 0.45 x squared, then minus 0.5 times 2, that is 1, that is just simply x minus x, and then negative 0.25. So derivative of 1.2 is 0. So we have our f prime of x. So now we want to determine what is our next value, which is f of x sub I plus 1, so approximately equal to f of 1, or sorry, f of 0, then plus f prime of 0 times h. So in short, our f of 1 is approximately equal to what is our f of 0, so which is the 1.2, then f prime of 0, so we'll get that one, so f prime of 0, so will be, so negative 0.4 times 0 cubed minus 0.45 0 squared minus 0 minus 0.25, so which is equal to negative 0.25. So that is minus 0.25, h is 1. So f of 1 then is approximately equal to 0.95. So we have 0.95 there. So our true error then, so 0.2, so minus 0.95 over 0.2, so times 100. Point 2 minus 0.95 over 0.2. So we have 375%. So for our approximate error, so we have current, which is 0.95, previous is 1.2 over current 0.95 times 100. 0.95 minus 1.2 over 0.95. So I have 26.5 32. $375. 32. So let's proceed with the second order. So the formula, so f of x sub I plus 1 is approximately equal to f of x sub I plus f prime of x sub I times h plus f double prime of x sub I times h squared over 2 factorial. But we already have this one, so which is equivalent to 0.95. So in short, so we need to find first, okay, so what is f prime of x, so which is negative 0.4. Okay, I'll just copy it. Then I'll get the f double prime of x, so will be 3 times 0.4, so negative 1.2 x cubed minus 0.45 times 2, so that will be 0.9 x, then minus derivative of x, it's just 1, and that will be 0. Then we can now get what is f double prime of 0, so which is negative 1.2 times 0 cubed minus 0.9 times 0 minus 1, so which is equal to negative 1. So we can now get what is f of approximately x sub I plus 1, which is 1, which is approximately 0.95, and plus f double prime, that is negative 1, h is 1 squared over 2 factorial. So f of 1 then would be, so this is 2 factorial is 2, so negative 1 over 2 is 1/2, or negative 0.5. So this would give us a 0.45. 0.95 minus 0.5 is 0.45. So this would be 0.45 here. So true value is 0.2. True percent, .2 minus 0.45 over 0.2, so times 100, so 0.2 minus 0.45 over 0.2, so it still have 125% error. And for our approximate error, so 0.45 minus the previous is 0.95. So which is 0.45. So minus 0.95. So times so we have previous by the, so this one so it even increases further, which is 111.11. $125. Then we have the fourth order. So for fourth order, so f of x sub I plus 1 is approximately f of x sub I plus f of prime of x sub I times h plus f of double prime x sub I h squared all over 2 factorial plus f of triple prime x sub I h cubed over 3 factorial. So this is the same as the first three is actually equal to 0.45 plus f triple prime of x sub I h cubed over 3 factorial. And then our f double prime of x is this. So I'm going to paste that. Then we get the triple prime. So negative 1.2 times 3 is negative 3.6 x squared, then minus 0.9. So that's our f triple prime of 0. So this is negative 0.9. So our f of 1 then is approximately equal to 0.45 minus 0.9 times 1 cube over 3 factorial. So which is approximately 0.45 minus 0.9 over 3 factorial. So which is 0.3. So let me add another page. So for the true error, so which is 0.2 minus 0.4, 0.3 over 0.2. So that is 0.1 divide 0.2, so times 100, so that is approximately 50%. Am I correct? 0.2 minus 0.3 over 0.2. 50%, so it's correct. So this is 50%. Then the approximate error .3, the previous is 0.45 divided with 0.3. 0.3 minus 0.45 divided with 0.3. So it's the same. So 50%. And lastly, so for the fourth order, and the f of x sub I plus 1 is approximately f of x sub I plus f of prime of x sub I times h plus f double prime of x sub I times h squared all over 2 factorial plus f fourth prime of x sub I f triple prime x sub I 3 factorial over, or h cube over 3 factorial 0, 1, 2, 3. And then lastly, f fourth prime of x sub I h to the fourth over 4 factorial. It is approximately 0.3 plus f fourth prime of x sub I h to the fourth over 4 factorial. And then, so what we have here is this one. The third derivative. So we get the fourth derivative of x. So this is negative 36 times 2, 72, 7.2 x, then that would be 0. Wait. Negative x cubed. This should only be x squared. Okay, so that's still fine. But then for the third order, so this is only third order. So 3 times 1 is negative 1.2, then x squared. And I'll have, okay, f double prime. So negative, this is only x squared. So instead of 3.6, that should only be negative 2.4. And then that would just be x, negative 2.4. So lastly, so this should only be negative 2.4x. And this would be negative 2.4. So our f to the fourth of 0 then is equal to negative 2.4. So therefore, our f of 1 is approximately 0.4 minus 2.4 times 1 to the fourth over 4 factorial. 0.3 minus 2.4 over 4 factorial. So which is 0.2. And from there, so we can say that our true error will be 0.2 minus 0.2 over 0.2 times 100, so which is 0. So we don't even need the approximate error here. So since we are specified right away, so what would be the number of iterations that we will be doing? So it's because this will not be 0. So we have 0.2, then minus the previous, which is 0.3 over 0.2. So times 100%. So which is equivalent to 0.1. Okay, so 50%. 0.3, 0.15 over. So 50. So this is 0.2, 0%, and 50%. Okay. So the approximate value then is actually 0.2. Okay, so we have the true percent error there, which is 0%. And that's how we solve using Taylor series. And that will be all. Good day.